There's a quiet assumption most of us live with every day. That life is mostly random. That accidents happen. That luck strikes or doesn't. That some things are just coincidence. We insure ourselves against this randomness. We accept it. We build our lives around managing uncertainty. But what if that assumption is only partly true? What if the events we label as random are not meaningless, but simply too complex to see clearly? Imagine for a moment two people sitting at the same table. One is a quantum physicist. The other is an insurance actuary. They come from radically different worlds, different languages, different tools, and yet both spend their lives doing the same thing, trying to understand the future, not in detail, not with certainty, but in patterns. This episode is not about proving that really is secretly controlled. It's about questioning whether randomness means what we think it means at all, and whether unseen structures, statistical, physical, relational, shape your life more than you realize. At first glance, insurance feels like the opposite of quantum physics. Insurance is practical, grounded, data-driven. Actuaries work with massive data sets: car accidents, floods, illnesses, human behavior. They don't predict your accident. They predict patterns across millions of lives. They know that any single event is unpredictable. But across a population, outcomes become strangely reliable. This is the quiet paradox of probability. Individually uncertain, collectively precise. Insurance companies don't rely on luck. They rely on structure. They know that what looks random at one scale becomes predictable at another. Now contrast that with quantum physics. At the quantum level, randomness appears fundamental. Particles don't have definite outcomes. They exist as probabilities. You can calculate the likelihood of an event, but not the event itself. And yet, and this is crucial, those probabilities are not arbitrary. They follow strict mathematical rules. Quantum mechanics does not say anything can happen. It says only certain things can happen with specific probabilities. Randomness here is not chaos. It is constrained uncertainty. Already something interesting is happening. The actuary and the physicist are both dealing with futures that cannot be predicted exactly, but can be modeled. Both accept uncertainty, but not meaninglessness. This is where the illusion of randomness begins to crack. We tend to think of randomness as the absence of order. But in quantum mechanics, this is formalized through probability itself. A structure clarified by physicists like John Bell, who showed that quantum uncertainty reflects how reality behaves, not just what we fail to know. Randomness often means something else, order that only appears when you zoom out. Take a single coin toss. Unpredictable. Take a million coin tosses. Perfectly structured. The same logic applies to traffic accidents, weather events, human decisions, and possibly to life itself. Quantum physics adds another layer to this. At the smallest scales, observation matters. Measurement is not passive. It plays a role in what happens. This does not mean consciousness magically controls reality, but it does mean that interaction matters. Reality is not simply sitting there, waiting to be observed. It responds. This idea unsettles our everyday intuition. This shit didn't come from philosophy alone. It emerged directly from 20th century physics, as thinkers like Niels Bohr began arguing that quantum outcomes don't exist independently of interaction. We prefer a world where causes are clear, linear, and isolated. But both quantum physics and actuarial science tell a different story. They describe a world of interdependence, where outcomes emerge from networks of conditions, which brings us to a powerful bridge between these two worlds: interconnectedness. You may have heard of the butterfly effect, the idea that a small change in one place can lead to large effects elsewhere. This is not mystical. It's mathematical. In complex systems, small inputs can amplify through feedback loops. Insurance models account for this indirectly. Quantum physics encounters it directly. Entanglement shows that systems can become linked in ways that defy classical separation. Two particles behave as one system, even when separated by vast distances. Again, this does not mean everything is secretly connected to everything else in a mystical sense. It means that independence is often an assumption, not a fact. Now bring this back to daily life. A choice you make in the morning changes your timing. Your timing changes who you encounter. That encounter changes information. That information changes decisions. From the inside, this feels like coincidence. From the outside, it looks like a chain of dependencies. Insurance models work precisely because these chains exist. They don't track every link. They track the structure of the network. Quantum physics suggests that reality itself may be built this way. Not as isolated events, but as evolving relationships. This raises an uncomfortable question. If events are not purely random, does that mean they are determined? Not necessarily. Between randomness and determinism lies a third space: constraint. A river is constrained by terrain, but it still flows. Weather is constrained by physics, but it is still unpredictable in detail. Human lives may be constrained by conditions, probabilities, and interactions without being scripted. This is where agency comes back into the picture. Insurance does not eliminate accidents. It reshapes risk. Quantum mechanics does not remove uncertainty. It defines its limits. In the same way, understanding structure does not remove freedom. It clarifies where freedom actually operates. Your life is not random in the sense of meaningless noise, but it's not controlled in the sense of a script. It unfolds within a web of probabilities, many of which you influence without realizing it. Now consider a thought experiment. What if risk models included not just historical data, but relational dynamics? Not just what happened, but how systems respond to observation, expectation, and feedback. This is not how insurance works today, but it reveals something important. Both actuarial science and quantum physics are trying to do the same thing: make sense of uncertainty without pretending it disappears. They accept that the future cannot be known exactly, but they reject the idea that the future is meaningless. This has deep implications for how we see our own lives. If outcomes are shaped by networks rather than isolated causes, then attention matters. Context matters. Timing matters. Not because the universe is watching you, but because you are part of the system. This brings us to the most subtle shift of all. If reality is not purely random and not fully predictable, then responsibility changes shape. You are not responsible for every outcome, but you are participating in patterns. Small choices matter, not because they guarantee results, but because they shift probabilities. This is not wishful thinking. It is how complex systems behave. Insurance understands this. Quantum physics hints at it. Life lives inside it. Your reality is not simply happening to you, but neither is it fully under your control. It is being shaped, moment by moment, through interaction. So what does it mean practically? It means that randomness is often a label we use when structure is too complex to see. It means that unseen forces are not mystical strings, but statistical, physical, and relational constraints. It means that meaning does not require certainty. And it means that understanding does not remove mystery, it deepens it. When a quantum physicist and an insurance actuary sit at the same table, they are not debating fate versus chance. They are exploring the same question from different angles. How does order emerge from uncertainty? And perhaps the most important insight is this: your life is not governed by chaos, but it is not governed by control either. It unfolds within a living web of probabilities, one you are already shaping, simply by being part of it. And once you begin to see life this way, something subtle shifts. You stop asking whether events are random or meant to happen. Those words start to feel too crude. Instead, you begin to notice patterns, not rigid patterns, not guarantees, but tendencies. You notice how certain environments shape behavior, how stress narrows choices, how calm opens them, how attention changes what you notice and what you miss. Insurance models are built on this insight, even if they never say it out loud. They know that human behavior is not chaotic. It is conditional. People drive differently when it rains. They behave differently when tired. They take different risks depending on context. None of this removes freedom. It shapes it. Quantum physics tells a parallel story, though at a different scale. Particles don't behave randomly in isolation. They behave probabilistically within constraints. The probability is not ignorance. It is structure. This is where many misunderstand quantum ideas. Randomness is not the absence of order. It is order that only appears statistically. And life at scale behaves the same way. Consider something simple. You miss a train by 1 minute. From the inside, this feels like bad luck. From the outside, it is the result of dozens of small conditions: timing, attention, traffic, mood, habit. Nothing mystical, nothing scripted, just a system unfolding. Now extend this idea. Careers, relationships, health, opportunity. Rarely do these hinge on a single moment. They emerge from repeated patterns. Insurance understands this deeply. It does not ask, will this person get sick? It asks, under these conditions, how often does sickness appear? Quantum physics does something similar. It does not ask, where is the particle? It asks, given this setup, where is it likely to appear? Different domains. Same logic. Which suggests something important. Reality may not be governed by fate or chance, but by conditional structure. This perspective quietly dissolves one of the most common fears people have. The fear that life is meaningless because it is random. If randomness meant chaos, that fear would make sense. But randomness in science does not mean chaos. It means unpredictability within rules. The weather is unpredictable, yet deeply structured. Evolution is unpredictable, yet remarkably consistent. Markets fluctuate wildly, yet follow statistical laws. Meaning does not disappear in uncertainty. It emerges within it. This is where the idea of unseen forces often gets misunderstood. People imagine hidden controllers, invisible hands, secret levers. But most unseen forces are not agents. They are constraints. Gravity is unseen. So is probability. So is entropy. They don't act with intention. They shape what is possible. Once you accept that, the universe becomes less mysterious and more subtle. The universe does not look like pure matter anymore. It looks like information under constraint. Physicist John Archibald Wheeler captured this shift with the phrase, "it from bit," suggesting that physical reality arises from informational structure. If the universe computes, it is tempting to imagine it running a fixed program. But some physicists, including Lee Smolin, have suggested that even physical laws may evolve, stabilizing over time rather than being fixed from the beginning. Now let's return to consciousness, because it cannot be avoided. If reality is shaped by probability, interaction, and constraint, what role does awareness play? At the human scale, awareness changes behavior. What you notice influences what you choose. What you expect influences how you act. What you believe possible shapes what you attempt. None of this requires magical thinking. It is basic psychology. But when awareness changes action, and action changes outcomes, and outcomes feed back into expectation, you get a loop. A feedback loop. Quantum physics induced a similar idea at the smallest scales. Measurement does not simply record reality. It interacts with it. Again, this does not mean consciousness controls particles. It means that interaction matters. Reality is not passive. From particles to people, systems respond to how they are engaged. This brings us to a deeper implication. If systems respond to interaction, then being part of a system means you are never neutral. Your presence changes probabilities. This is not a burden. It is simply a fact. Insurance models assume this all the time. They know that behavior shifts risk. That environment shapes outcomes. That intervention changes trajectories. Quantum physics hints at the same structure, but at a scale where intuition breaks down, and life lives in between. At this point, some people worry. If everything is interconnected, if outcomes depend on countless factors, does that mean responsibility becomes overwhelming? No, It means responsibility becomes localized. You are not responsible for the whole system. You are responsible for your participation in it. A single drop does not control the river, but it contributes to the flow. This reframing is subtle, but powerful. It removes the illusion of total control without collapsing to helplessness. It acknowledges influence without demanding certainty. This is where many philosophical systems fail. They swing between extremes. Either everything is controlled or nothing matters. But complex systems do not work that way. They allow meaningful influence without predictability. That is not a flaw. It is how adaptability emerges. Seen this way, the idea that your reality is shaped by unseen forces becomes less dramatic and more accurate. Those forces are not supernatural. They are statistical, relational, physical. They are the same forces that allow bridges to stand, insurance to function, and ecosystems to survive. Quantum physics does not add magic to this picture. It removes naive certainty. It tells us that at the deepest levels, reality is not fixed until interaction. Insurance does the same at the human level. It accepts that the future cannot be known in detail, but refuses to treat it as meaningless. Together, these perspectives suggest something quietly profound. Your life is not a lottery ticket, but it is not a script either. It is a process unfolding inside constraints. Now consider how this changes everyday thinking. You stop obsessing over outcomes. You start paying attention to conditions. You ask not, will this work? But, what environment am I creating? You stop treating chance as an enemy and start treating uncertainty as a space of possibility. This does not guarantee success. Nothing does. But it aligns your actions with how reality actually behaves. Insurance does not eliminate loss. Quantum physics does not eliminate uncertainty. They teach us how to live intelligently with them. There is another consequence worth noticing. Once you see that randomness often hides structure, you become less afraid of not knowing. Not knowing stops being ignorance. It becomes openness. Science itself operates this way. Every model is provisional. Every theory is incomplete. Progress does not come from certainty. It comes from refinement. Insurance tables are constantly updated. Quantum theories are constantly revised. Reality does not punish humility. It rewards adaptability. At the deepest level, this episode is not about quantum physics. And it is not about insurance. It is about how humans relate to uncertainty. Do we treat it as chaos? Or as complexity? Do we surrender agency? Or do we engage intelligently? The idea that unseen forces shape your reality is not meant to frighten you. It is meant to ground you. You are not at the mercy of randomness, but you are part of a system larger than yourself. Your choices matter, not because they control everything, but because they participate in something real. So when a quantum physicist and an insurance actuary sit together, they are not revealing hidden strings behind the universe. They are reminding us of something quieter, that life unfolds with patterns we rarely notice. That uncertainty is not the absence of order. That meaning does not require certainty. And that understanding reality does not strip it of wonder. It deepens it. Because once you stop demanding guarantees, you start noticing how alive the process really is. Not random, not controlled, but responsive. And that may be the most accurate description of reality we have.